Hello, I'm Stephen Cook with Cook Saw Manufacturing, and I want to tell you a little bit about our company and then show you about the MP-32 model and how it operates and works, and some new and innovative things that we've done to it recently. First of all, Tim Cook, my brother, and myself, I'm Stephen, own Cook Saw Manufacturing, and we have been manufacturing sawmills since about 1994. Our company began many years ago, over 40 years now, when my dad started a saw repair business. He was a minister, a preacher, and he had 3 growing boys, and we all needed more food to eat. And so he asked the elders there at the church, and he started doing a saw repair business. His daddy, before him, actually began. If you've ever seen some of the old Foley bell saw advertisements, that's how my grandpa started in the saw repair business. But my dad started along the time I was probably about 10 years old, and I'm the youngest of 3 brothers. And he began doing saw blades, circle saws, skill saws. And it wasn't too long until some people from Sawmill started calling on him, and he began to learn to hammer head saw rigs for the circle saw industry. And we did that for many years, 20 years or more, I'm sure. In the meantime, he bought a machine shop, and an old machine shop. And as us boys began to get out of school, we began working and doing things in the machine shop, and that's how we slowly moved into manufacturing. Tim and I, and my older brother, were all sharpening blades probably when we were 10 years old. So we have a long experience in that, and Tim and I also have done pulpwooding. We were young boys pretty much, things you probably couldn't do nowadays, but at 14 and 16 years old we were sawing trees down, logging, and Tim was driving the truck over here to Cedar Springs, Georgia, and carrying pulpwood to the pulp mill. So we did that. We've got experience with a wide variety of things, from sawing trees and skidders to sawmills and saw blades. We've been doing this again since we were children, basically. And so using all of that experiences and the hundreds of blades, thousands of blades that we've sharpened and re-tipped, our dad eventually got into wide band saws and did wide band saws. And then when we began manufacturing for the portable sawmill industry, we began selling the thin curve, narrow blades. We still sell 400 to 500 blades a day. And we have serviced this industry. Tim is very mechanical and understands all kinds of things, and he's literally helped hundreds, if not thousands, of people run their sawmills better. So we try to serve our customers. This is a industry that we enjoy. We feel like we relate very well with our customers. We've come up doing a lot of the things that probably you are doing or wanting to do. Everything from building our own houses to horse barns and all the way to the pulpwooding. So we've done some of all of that and feel like we can relate pretty well to you. We enjoy the outdoors and just working with trees and woodworking. We've built cabinets and done a little bit of everything, done flooring, so all kind of things. And so we enjoy telling those stories and enjoy helping you with your sawmills. This today I want to demonstrate our MP-32 model. It's manual and portable. We have added some 12-volt options to this one, but and it'll cut a 32-inch log. Now this log that we've got on here today is this is 15 inches on the small end. That is a good size log. We advertise this mill as a hobby mill, and that is what it is, but it is a very heavy-duty hobby mill. Probably if you're looking for a sawmill, this would be the most heavy-duty mill that is out there, I think, as far as the sturdiness. We really have taken our AC-36, our AccuTrack, we began calling it. Now it's pretty much just called a Cook's portable band sawmill, and which is a 36-inch mill with 26-inch diameter band wheels. We were some of the early ones to do that with the bigger mill, but we've scaled this mill down. It's got a 19-inch band wheel, a standard in the industry, but a lot of the same features. We have 2x2 tubing, 3/16 wall on this head. It's welded together. It is very sturdy and strong. We use the twin rail system. Again, we've been doing this since the early to mid 90s, and so this is a very proven mill. Most people do use it as a hobby. Some people actually make a living using these mills, but we do sell it as a hobby mill. But again, it's very heavy duty, and don't let that fool you though. It is also very easy and portable. You can move this easily with a half-ton pickup truck. Some people even pull them away from our place with a van. So they'll do easy to move around. I would say very similar to a bass boat or something of that nature. So we like it being heavy duty. This is a sawmill that you can buy and pass it on to your children. It's just really a long-term investment. No matter what you're wanting to do, if you're wanting to build a house or build stables, this is a sawmill that will serve you well, and you can count on it. So I want to just show you some things about it. We'll move around the sawmill as we go, and just show you things that probably would be of interest to you and that would help you in making a decision to buy the right sawmill. Okay, this is kind of our new look. We're putting metal doors on. We used to use wood doors, and there were some things we liked about those, but the customers seem to want metal doors, and so that's something we've put on with a swing out. Real easy to use there, easy access to your wheels here. Same thing on the other side. The other door will just swing out just like this. While I got this door open, I'll show you our band wheels. We use metal band wheels. I mentioned they're 19 inches. They do have a little crown in them. If you're ever running a sawmill and it doesn't want to track, the blade wants to run forward and you readjust the tracking and then it runs backwards, most of the time that's because there's no crown in that wheel. So the crown is just a little hump in the face of this wheel out here. And so that's what makes that blade track properly. So we have a little crown in that. We have used, some people sometimes are critical about one thing or another, and sometimes they are about steel wheels, but we've used belted wheels, we've used urethane wheels, and now we use steel wheels. And what we try to do is to use what makes sense and use what is best. Literally, it's more expensive for us to use these metal wheels, and so we don't do them just for just no reason. We're doing them because we believe that they're better. They don't get cut. As urethane can. The belted wheels, number one, most people are using sheaves here or belt pulleys and putting that belt in, and those pulleys are not true. And so we have spent a good bit of time and money coming to understand how to best run blades and what gives the best life for these blades. And what we found is the belted wheels, they're usually out of round. The sheave is out of round. Sometimes you have a loose belt, they call it, and sawdust is going to get under it. You can actually see sawdust on this wheel right here build up on it, and that's on that crown spot is what it is. Well, that builds up on those belts. It goes up under the belts. You get all kind of things that can happen, and anything that's a hump there makes that wheel out of round. So we like these the best, and that's why we use them. Something else that we do, this has a bearing inside this wheel on the idle side. We just, through experience, found that's what lasts the longest and works the best. It's a sealed bearing, and so you don't even have to oil this side. But we put that on there, and we mount this shaft up on a machine, and we turn this wheel mounted on this shaft. Same thing happens on this other side, although does have a bearing over here. It's called our drive bearing assembly. We have a split tapered bushing that goes on that shaft. It is all mounted together. And we put that bearing with that wheel, with that tapered bushing, and we actually grind. We've built a machine to grind the crown in this and make sure it's true, number one, so it's not out of round, and then to put that crown in there. So we have as near perfect a wheel as you can get. We like to see them within about 3 thousandths. We have found if wheels get out over 12 to 15 thousandths, that band breakage will become greater and sometimes even very excessive. We've helped people change their wheels out, and they go from just having a blade eating machine, we call it, to one that they all of a sudden they say, man, I don't know if I'll ever break blades again. And of course, actually we run our blades till we break them. We want to get everything we can get out of them, but they get real long life. Now here is something that we've done that, although it's really simple, is pretty innovative, we think. We have, of course, this is our tank with the fuel or the solvent inside the tank here. It comes down through a filter and a dripper valve with a sight glass, so you can just see it drip. But the innovative part, though it's very simple, is a felt wiper here that we mount up, and it actually rubs and touches, sticks out the bottom here of this metal and touches that band. And so we're wiping, in this case, if we're running with pine, we'll use diesel fuel. Some people use pine sol, and there's other solvents you can use. But it's important that you don't allow this tar to get too thick on here. And really where it's most important, that it don't get thick on the blade itself. And it will build up on there if you don't have some kind of solvent. And if you're sawing along and been doing good, maybe running soap and water, or just water in oak trees or something, and then you get some pine or other tree that might have a lot of sap in it, and it begins sticking to that blade. I've seen blades that have so much pitch built on them that they're literally twice as thick as they normally are because of that pitch build up on them. But this wipes it on there, as compared to others that we even have tried in the past where you're just trying to drip it. And when you drip it, there's wind in here from this blade and the set of the teeth, and maybe just the wind blowing itself out here, out in the open. And it's hard to make it land where you want and do what you want. Well, this controls it. It's really very simple, fairly inexpensive to replace, and so we get to keep that blade clean. Just so very critical in running that blade. This is our roller guides. We have a roller guide on the in feed and the out feed side. We have a little blocker here. You can see where this sawdust is building up on it, and that's just above the band blade, and that's to keep a chunk of wood and sawdust, so much of it, from going underneath the band and going in underneath the wheel. It does go on out the dust chute on that side, and but that just knocks it down. These roller guides are 8-way adjustable. They'll go up and down, in and out, and then they tilt from top to bottom and side to side. All those adjustments are very important, and there are different types of guides out there, but for the portable band sawmill, we believe that the roller guides are the best. You can control it. They seem to give you a little bit better blade life, and so it's very important. Our roller guides are precision made. We have seen roller guides that are not precision made, and they actually have a little bit of they're out around 5 thousandths or so, and that thing will beat your blade. You don't want anything beating on that blade, yanking on that blade. If your wheels get out of round, they begin to yank on it. It's so funny how it'll be smooth. You can literally watch blades on sawmills, and they'll run smooth, just real thin, and then all of a sudden you'll see them start vibrating, and that's because of those wheels I was talking about. You want to see that blade running real fine and true and not vibrating a lot. If you see that vibrating a lot, you've got problems, or you don't want to buy that mill. These roller guides are hardened, and they're made on computerized machines. They're hardened, and then we actually grind these true as well. We put them on a spindle and grind them so that they're absolutely true. Many years ago we didn't do that, and I think other manufacturers probably don't do that finish grind. It takes a little more time, takes a little more money, but it makes a better product. I'll close this door up, and we'll we'll move to another position and show you some other things. Okay, we're still on the idle side, but I wanted to show you right behind where I was standing a minute ago. To begin with, this is our tension handle. It goes right in this this slot right here, and we have a spring tension, and just by spinning this handle you loosen it, or spinning it the other way you tighten it up, and it tightens against the spring. That's held right there. Our tension tightens against the spring. It's an 850 pound spring. We run about 15,000 to 18,000 tensile pound. We do a lot of experimentation with running blades just to see how long they'll run before they break. And we have found, hey, we can run this thing at 18,000 tensile pound or 20,000 if we wanted to. And we can saw a little faster sometime, but it shortens the blade life. And we found if we'll get down into the 15,000, 16,000 tensile pound, that still gives you a good, you got to have a good blade to start with, a good stiff blade. But by tensioning it up to about that range, it gives you a good stiff blade, holds it good and tight, and you can saw at a good rate of speed, and you get even more blade life. And so we found this is kind of a teetering point, I guess you would say, around the 16,000 pound, and you can go up more and still get some good life if you want to saw faster. But that's something that we encourage people to do as they saw, and go, okay, I want to saw a little faster, or need to saw a little faster. Sometimes sawing faster is worth more than the cost of the blade if you shorten the life by 2 or 3 sharpenings or something. So that's how that works. Now we use a spring tension. Again, different people use different things. They use a hydraulic, or some people use a manual screw with a torque wrench. They do all kinds of things. We like this the best because what we're doing is we are actually tightening up against the spring. We have a marker here. It comes out in this slot, and we know that we're tensioned up when we do that. And it doesn't matter if a blade's a 1/2 inch shorter or a 1/2 inch longer. We always still tighten up against the spring, and then as we compress the spring, that's when this mark comes into place. And we can tension that thing up. It's the same every time. And just by turning a little extra one way or the other, we can make that thing track right into place, and it just does a great job. One reason we're not fans of a torque wrench type thing, with all the pressures that are involved with these screws and these mills, when you're putting 15,000 pounds of tensile pounds on a blade, there's a lot of pressure in there, 850 pound spring. Things can galled up, and if you're using a torque wrench, well, you may torque that bolt, but it may not actually be giving you the same pressure in against tightening on the blade itself. It may just be binding out, and we find that's an issue even with just hydraulic types. You may get a PSI, but sometimes they're on rods and different things, and they can bind out, and you never get that exact pressure. We have a hinge here that's easy to move. And so when we tension it up, it comes out. The other thing that we're really sold on the spring about is that it'll hold a constant pressure, but as sawdust goes through, I showed you the sawdust on the wheel, well, that wheel got a little thicker. And when it did, it puts if it was a dead tension, it would put more stress on that blade. It puts a hump down through there, actually, sometimes. A piece of bark can go up through there, and does go up through there from time to time. And then that can damage your blade. And so that's what we like about this spring. It gives a little bit of give, and we think is more forgiving to the blade. And again, we really work on getting blade life. That's what our customers seem to want and need. I mean, makes sense to have longer blade life, and we spend a lot of time talking and studying and thinking and trying things to get blade life, both in the blade itself and on our machinery that we sell. So that's how that works. Right here, and you'll see this on the other side as well, there's 2 plates and a hinge point right there, a pin, and that is for tracking this wheel. On the other side there is just these two plates, and it's for tracking that wheel. That is set from the factory, and you shouldn't have to fool with that or mess with it really at all. If you do, then probably your crown is beginning to wear out after 6 months or so, and that, you know, you can call us, talk to us, and we can tell you some about that. But then this hinge is where it swings out and tensions the blade up. We've got our blade guide on this manual mill is just a T-handle that you pull, and you can move this in and out wherever you want to. I generally move that out to a position that is pretty close to where I think most of my logs will be, and I just run it probably 3/4 out, and then I don't have to move it in and out and be dealing with it. Another thing that we do, and I think a lot of people do this, but some people don't, and that is we use a belt engaging, an idler arm that engages our belt. And that's what drives the drive bearing on the other side, gets it spinning and makes the blade spin. Now why we use that is just because we think it is more simple and better. Our experience again with clutches, I've heard people talk about it, and sometimes people think they want them, and every time we've tried them, it just seems like it's a lot of trouble for the customer and for us, because we've put something on there that doesn't seem to be the best fit. This just seems to work better. We leave it engaged. We're not trying to speed the engine up and slow it down. We just don't feel like that's good for the engine, dumping gas in and you know, speeding it up from slow to fast, and then cutting it off every time. We just leave it running at a good rate of speed, wide open if we need to, or a little slower if that serves our purpose. But clutches seem to have problems, and they get very expensive, and so in the to have the best benefit all the way around, we have just stayed with this belt system. It seems to work very well and has much less problems, and it gets the job done. This is our gauges, our scales for sawing. We have different scales actually, but there's 4 here. This is just a regular inch scale, and that will tell me how thick my can is as I'm cutting it, my log as I'm cutting it down. Our pointer stays stationary, and our scale moves up and down. That gives you a more accurate cut from where you stand. It's always accurate. We have a 4/4 scale, 5/4, and 6/4 on here, and these are for would be a hardwood scale. And there, if you're familiar with that, they're actually 1/8 over. So a 4/4 would be 1 1/8, 1 inch and 1/8. So it's an 1/8 over is what we do. So you can cut that a little bit thicker for the hardwood scale. And you can use this, a lot of time I'll just use, and I probably will today, use the 6/4 scale because it's cutting 1.5 inches plus 1/8, so 1 5/8 inches is what it's cutting. So the time my board shrinks a little bit, that works out good for a rough cut board. It ends up being so close to what you would buy from the store. These are magnetic. I mentioned we have several different ones, so they just on a piece of magnet there, sticks on, stays on very good. It'll ride up and down the road. You don't have to worry about it blowing off. And so if you want one of the other scales, we actually have a full, what we call a full 1 inch, a full 2 inch scale. So you can just drop from that. You get to the size you want. Say you've got a 12-inch can, and you say I want 2x12s, and you want a full 2x12. You would cut it down to here on your regular inch scale, and then you would have the full 1 inch or 2 inch, and you would just drop from line to line, and you would get the full 2 inch board there. And those things look huge when you do that. But if you have a customer, if you're custom cutting, or if you just, I kind of like to build my stuff a little thicker, a little bigger, a little heavier, you know, if that's just what you like to do, then we have that accommodated too. On this mill, it is the MP-32, but in this case, we have the 12-volt options on it. We have a 12-volt motor up here that is hooked to a belt that turns through a gear ratio and raises this head up and down. So just by moving this lever, I release this brake with my right hand, and I press the up or the down, and it will go up and down power fed. That's really nice, especially when you're cranking it up. When you drop it down, if you go with just the the regular MP-32 without this option, you have the same gear ratio and this handle, and you crank this handle. Now when you take that motor off, it's much easier. Of course, cranking it up is harder. Coming down, you can just pull the brake and let it ease down and drop it down real nicely right to where you want it. But for the raising of that head up, that 12 volt is just makes it so nice and so easy. Then we also have the forward and reverse with a 12 volt motor here. And it just pulls down the chain from the inside, and by pressing this button right here, I can make it go forward. I press the bottom on this little handle and it comes right back to me. So we have a potentiometer where I can slow that down to just a crawl, or to nothing actually, just a crawl, and we can move forward. Small logs I can speed up, big logs I can slow down, but then when I come back we have the full speed that it goes on the way back. So that's how that works. We use Kohler engines. This particular model has a 30 horsepower engine, and we have all sizes up and down the scale that you can choose what you want to put on there. They all seem to do very well. Of course, the more horsepower you have, the better you like it. Okay, we're here on the drive bearing side, or the drive side, and this is our drive bearing assembly, we call it. It has the belt sheave over here, the belt pulley, and it has the drive band wheel on this side. On this side, the shaft is 2 1/8. On the belt side, it's 1 7/8. We start with a very large shaft, and we turn this down. We do this in our machine shop on computerized machinery, and we turn this down and make this shaft just as large as we can in here, making the journals good and round and smooth, so they just fit on these tapered roller bearings. So we've got a tapered roller bearing on one turned out this way and one this way, and that is screwed in or tightened in with a huge nut right here, so that we can bring it in with the right pressures. And we have found that that's very critical. Again, we don't do this because it's the cheapest. The cheapest would be to put pillar block bearings there. We've done that in years, but many years ago. But we found a lot of things happen. Everything from breaking the housing itself, even on an 1.5 to 2 inch pillar block bearing, you can break that housing. But even, well, maybe not even more, but something that happened more often is, for whatever reason, those pillar block bearings can't stand that pressure. It's the overhung load. And so by putting this large shaft, we've gotten bigger and bigger through the years. We put a large shaft inside a seamless piece of pipe, DOM they call it, and we machine that out on the inside. Everything about that is machined, and we do retrofit or sell them to people to retrofit on their mills, and we've replaced quite a few through the years because they were having the same thing that we had found out, pillar block bearings. And when people are tensioning tighter, all these things come into play, especially those pillar block bearings have problems, and a lot of times they'll go out every couple of weeks and just drive you crazy. So this has been our solution and has worked very well for us, and we've spent a lot of time and experimentation perfecting that as well. So of course our gas tank is right here. We've got it down low so that you can get to it, pour gas in it. I mentioned our fluid tank is right here, and it drips right down there. Just a good heavy duty mill. Our head frame is made out of 3x6 tubing. Just a good stout mill, so it can withstand the forces that we put against it. And again, it's a machine that you can pass on to your children. I do want to show you now the bed, so we'll move around and we'll talk about the bed and the clamps just a little bit, and then we'll be ready to saw. I wanted to show you the bed frame here, of course, made out of 3x6 tubing, the twin rail. I think we mentioned earlier. We've added stainless steel bed caps. That's something that we never thought of necessarily as a necessity, but some people wanted them, so that's something we try to listen to our customers, and we've added those recently. Make it look nice for sure. This is what we call our squaring arms. They are at 90 degrees to the bed or to the bunks here, and so when we cut that log, we can turn it up against it, and that gives us 90 degrees. The way we cut the log, since it is manual clamping, we are sawing from this side and throwing the sawdust out the other side. and that pulls against these arms, and that's a benefit there. We like to stay out of the bark as much as we can, so you can make your choice about this, but by cutting the top off, turning that all the way down and cutting the top off again, you only get into the wood, to the bark side, the dirty side of the log 2 times, and then you would turn it up against this and cut it so that you're getting down into clean wood as you enter. But you can cut the face and turn it against this if you want to the next time. But that keeps you cutting into the bark more often. But whichever is easy and works best for you is good. We have both of these square arms tied together here. You can do it right here if there's no log, but usually there's a log there. So we put this down here. I like to use my foot. I'm getting older, and so bending over is a little hard. But you can push it with your foot, raise it up. Sometimes you want to kick it a little bit because the log may be against it or whatever. But we hook those together. When they're all the way down, they're out of the way. These lips right here hold the log and the edge of the log. Once you get it down 8-10 inches, just be aware as you go into it, because you can jerk it off if you don't have these up. But if you've got a nice 10 or 12 inch wide log and 10 inches high, you usually don't even have to clamp it or put the squaring arm up. When it's round and it wants to roll, certainly have that up. You'll find that a lot of times when you clamp it, you can just clamp with 1 clamp. We do have 2 clamps, because there's times that you need 2 clamps, and so we put them on there. But these are very simple to use. This pivots, makes this pin pivot back and forth, and when you push it down, it's on an eccentric, and it locks it so it don't. So you have this up, you shove it against the log, and you pull it down. That's how they both do. we've sawed up this log. We didn't saw it completely up, but sawed enough that you could see what we're doing. I'm not a sawyer. I'm in the office more than I am out sawing anymore. And so I wasn't trying to saw at the fastest speed. I was sawing at a pretty good speed, I felt like. But that's a 12-inch board. Yeah, 12-inch board. I cut that right at 2 inches thick. I'm just a little under that, but that's what I wanted, was something about that thick. It's about 1 7/8. So when you see a real 2-inch board, that thing is huge. But cut real good. I cut this piece right here just for the fun of it. That's always impressive to me, and I hope impressive to you, how thin that is. I just went at a 1/4 inch, and you can see just uniform. Perfect cutting machine. When a machine is right, that's what you can do. I could even actually cut that thinner than that if I wanted to, but I was swinging it around here and I cracked it a minute ago. But you can just see, you can almost roll that thing up. So that's just really impressive to me to do that. But when you've got a good cutting machine like our MP-32 is, you can cut wide boards. You can split this up and turn it over. You could cut that at 6 inches, turn it over and cut two by 6s at a time. We say that you can reasonably cut 1,500 feet a day, 1,000 to 1,500 feet a day with this mill. I've heard of people cutting 2,200. You probably need to have an extra helper or two if you do that, and have your logs and everything set up. A lot of cutting more lumber is in organization, not necessarily the speed of the saw. Getting that log turned, having people ready there to help you, you can really up your production that way. So the blade cut's good. I probably could cut a little faster than I did, but I didn't want to try to overdo it since I'm not don't saw all the time. So hope you enjoyed this video. We do appreciate your interest, and we just ask you to give us a call if you have interest in a sawmill or an edger or sharpener. We've been building equipment a long time and have a good understanding of the industry. We appreciate it. Thank you.